Hello, welcome to Mr. Lamb Science Corner. Today we're going to look at the history of the periodic table. This is the modern version. It's not completely in order because it lists a couple. They put down some place names, thinking in their wildest dreams that these would actually become the names of the elements. Unilhexium, unilquadium, unilpentium. There basically wasn't much chance in doing that because people who discovered them have long had the ability to name the elements, and in the last 50 years or so, that's occasioned a lot of fights. I tell my students, because I taught high school, that we should be very happy that the Russians didn't get one element named because they were going to call it Kirkachovium after probably a very nice man named Kirkachev who did a lot for physics and chemistry and is well worthy of the name, but it unfortunately had the symbol for it was going to be the initials of our arch rival Klamath Union, or Kirkachovium would have been KU. And I told them that was just, we couldn't do that. But be that as it may, that most of you don't have that problem. The periodic table, and I wish I could have found it, but there's a great cartoon of two people standing around in Greek or Roman outfits. I think they actually were Roman togas, but they were supposed to be Greeks. And it had Plato introducing what he called the periodic table, which was just a list of 4 elements: earth, air, fire, and water. But he was the first one to talk about elements, and he did it about 330 BCE. The E this stands for before Common Era, and that's a whole different discussion. But we'll postpone that for now. So anyway, so the first 4 elements that were called elements: earth, air, fire, and water. And they added things like mercury and sulfur and things not as elements per se, but as kind of add-ons to the elements. And fortunately, we don't have any of that. The first element seen as an element and was discovered as such was by a man named Hennig Brand, who in 1669 discovered phosphorus. And he did it by taking the urine from his family household and all the maids and butlers and whatnot in there, because he was a fairly rich man. And he collected all the urine from the household and then boiled it down. Probably don't want to visualize that. But when he boiled it down, he then got a mass of all the solids from the urine, and he took out the nitrogen, he took out the oxygen, he took out this and the sulfur, and he took out different elements that were known at the time, and he was left with a mass of material that was unknown. And he called it phosphorus because phosphorus in that form glows in the dark, and he used that as a thing to get people to his lectures, and he did performing for rich people. He painted phosphorus compounds on their skin, and they glowed in the dark, and they had fun, and probably a few of them died because of phosphorus poisoning and whatnot. But anyway, he had a lot of fun with it. It also spontaneously caught on fire, so there were some problems with that. But he's the one who came up with it. And I always told my students, told the story about the urine, and they thought that was gross and all like this, and it is. But I told them, you can use that to help remember the symbol for phosphorus because it's the letter P. Okay. So anyway, he's the one who came up with the first element, 1669, as seen as an element. The others were kind of known. I mean, they knew about iron and gold and silver and nickel and zinc and a bunch of others. But this was first discovered as an element and seen as an element right away. Okay? In 1651, going backtrack a little bit, a man named Robert Boyle, who is very well known in physics and chemistry as the guy who came up with Boyle's law. I always tell students that if you get something named after yourself, you're probably pretty hot stuff. So in gas law, Boyle's law is pretty big. But he also defined the term element. He gave a definition for what an element is. Okay, and I'll leave you to look that up. Give you a push towards getting on the internet. A man named Johann Duberreiner, and I know I'm mispronouncing that name because I had a couple of German teachers try to teach me how to pronounce it correctly, and I thought I was saying the same thing, and they said no. So anyway, but the little umlaut here. In 1817, came up with as a concept of something called triads. You take a look at elements. For example, if you take a look at elements in the same grouping here, we'll talk about what that grouping is called later, but lithium, sodium, and potassium, if you look at the two elements on the outside, then the element in the middle has properties about halfway between the two. And he pointed out a few triads in here. Now, the periodic table was quite different. For example, this column right here didn't exist. They didn't know about any of these elements. But so you could look through here, and he came up with the concept of triads. We haven't talked about the Karlsruhe Conference in 1860, but we will. Very important conference. It really did some big important things. But because of that conference, John Newlands was able to go back and look at some really good atomic weights, and he arranged a periodic table by periodic weights. And so if you take a look at the periodic table, hydrogen weighs 2 because it's 2 atoms together, and we just increase, for the most part, most of the elements. If you take a look at 2 side by side, the one with the next one after it's going to be way more than the one before, but not always, because while as good as the periodic table was for John Newlands, we had one even better with Dmitri Mendeleev, who came up with one just 5 years later, 1869. And what he did was he took basically Newlands came up with the law, what he called the law of octaves. Okay, I'm sorry, I'm jumping back again. Again, this column doesn't exist. Okay, so forget this one. If you 1, 2, 3, 4, 5, 6, 7, and then 8, sodium is very similar to that of lithium. And if you go 1, 2, 3, 4, 5, 6, 7, 8, potassium is very similar to that of sodium. So he came up with what he called the law of octaves. Unfortunately, if you count here, you go 1, 2, 3, 4, 5, 6, 7, and then back to 8. It falls apart very quickly. So the law of octaves, while helpful, wasn't as helpful as you might imagine. So Mendeleev came up and he did a couple of major things. One is he shifted a couple of elements with their atomic weight, and he said, based on their properties, not on their atomic weight, they belong like this, not like that. And so, cobalt, nickel. If you look at the periodic table with atomic weights, this doesn't have them. You'll see that the one that comes first, cobalt, is listed with a higher atomic weight than nickel, which comes second. And it's kind of hard to see that because I've looked at the properties of cobalt and nickel, and they're very similar to each other. So he had to be really good to see that there were subtle differences causing him to switch them. Tellurium and iodine, way over here. Tellurium definitely belongs in the oxygen family, and iodine belongs in the halogen family. So it was real easy to see to switch these two around. It really truly was. It doesn't take a super genius to switch these two around. It really did for these two. Okay, cobalt and nickel. But he switched them around, and if he did just that, it would be okay. But the big thing he did is that he left spaces for 3 elements, and actually predicted properties of 8 elements. And he said, you know, it's really too big a jump with the known elements we have now. I tell you, there's an element there, and sure enough, they found gallium, germanium, and scandium. Okay, so gallium, there's germanium, there's gallium, scandium is way over here, and he just said there's elements there. And not only did he say there are elements there, but based on the law of octaves and the law of triads, he said here are the properties. And he predicted a bunch of properties for them, and when they actually found the elements, he was within 10% of being correct, which is pretty good for something that's not known. And he was very specific. He said the boiling point of a chlorine germanium compound, and he gave a number, and they were within 10%. I mean, that's pretty good. And so, unfortunately, when he came out with this in between 1869 and 1875, basically wasn't paid attention to. And the reason for that was really parochial. He was Russian. And at the time, Russia did not have any kind of scientific reputation whatsoever. Similar in many parts to America. In 1869, we had Benjamin Franklin, way back when, 60, 70 years before, and even before that when he'd done his scientific research. And that was about it. I mean, we had some up and coming, and we had an explosion of scientific research just about that time. But in terms of reputation, America didn't have a reputation, but when we got a reputation, because when we wrote scientific papers, we wrote them in English. And so people in England read the papers, and they got a hold of other people, and they invited them to conferences, and like it. Mendeleev wrote in Russian. And nobody in the scientific world read Russian because at the time, he was very popular. The political leaders in Russia were proud of the fact they were illiterate. That a Russian noble hunted, fished, did all those manly men things, and reading, that was for the kiddos, if that. And the boys, never. You teach them how to hunt and fish. And so he comes along and he prints this, and he actually went and spent some time in Germany, and that got people starting to read his stuff, and when they discovered the elements that he had predicted, they said, there's probably something to this, and there certainly is. And then the last one we're going to look at is Henry Moseley, which I've there's a video on Moseley, so I'm not going to do a whole lot here, but 1913. Uh, and he came to an unfortunate end in World War One. But the very quickly, there's a lot more to be said about the periodic table. Going across, these are called periods, and there's 7 of them. If you take, although 1, 2, 3, 4, 5, 6, 7, 8, 9, you might say, wait a minute, there's 9 periods. These 2 rows actually belong right here and here, kind of stacked up this way. But that's kind of hard to show on a piece of paper. So they put them down here, and if they discover any new elements, they're going to have to do something else, because they'll start a new row, and then they'll have to put somewhere, because it's going to, like I said, we're talking about the history of the periodic table now. I'm not talking about the organization too much. Although I will tell you that these are called periods, and these vertical ones are called families, mostly on the outside. The stuff in the middle don't follow the rules quite as easily as the ones on the outside. But you have the alkaline metals, the alkaline earth metals, you have the inert gases, the halogens, the oxygen, nitrogen, carbon family. For some reason, it's called the aluminum family, not the boron family. So anyway, so that is the history of the periodic table.